portfolio. Right. So, good morning, afternoon, and evening, everyone. Thank you for joining the Link Digital Public Forum. And again, I've mentioned earlier that so many familiar names, and welcome to those first time who joined the forum. Before we get started, we'd love to hear a quick introduction from each of you by sending a chat. Tell us your name and say hi. And also, please feel free to use the chat feature for questions and feedback. The session will be recorded and will be published to the Link Digital YouTube channel. So, without further ado, introducing our virtual host, Stephen DeCosta.
Yay. Thank you, Kate, as always. Okay, so as usual, I have some updates. I'd like to just go through some quick updates before I introduce Claire, who is our speaker today, and she's awesome. So she will have lots and lots of info. My updates are very brief. I can get them out of the way very quickly. So one thing is CCAN demo days for folks who remember Open Data Day. We were collecting some videos, and we wanted to also put those videos from the link collection of demos into the CCAN YouTube channels as well as a playlist. That's not quite there yet, but I'm still trying to follow that up and get that made. But it will be an open invitation for others to create their own demo day videos into the future. Not just restricting it to one day as part of Open Data Days, but try and make it an ongoing process or an ongoing program over the year ahead. That's my intention, that's my belief, that's my hope, and I'll be working on that for the rest of the year with Alex Gustav and others. CCAN Sync, we had a cool blog post, I think it was the 24th of April, that went up with our first module on Drupal.com, and it's a CCAN Sync module for Drupal. If you want to check out the CCAN Demo Days video collection, there's a run through of how that works, but the blog post also covers that a little bit. And we'll be looking for contributors and people interested in kind of logging in and checking it out. Also on CCAN stuff, bit of a theme going. The Tuesday tutorials with Brett are being posted at the moment. So we've had 2 go up in the last couple of weeks. And these are kind of like the Sergey ones, where Sergey had his Tuesday tutorials videos. Brett actually started this whole thing. There's a bit of a race going on between the 2 of them. Brett was doing all the installation videos prior. And now Brett is following up some of those with blog posts as well to make them a bit more accessible to folks who just want to have a read through, click on the links, and jump into it themselves. And then the last one is kind of the big one. So we've got an initiative kicking off at the start of April, working on some core CCAN work from Link. So funded Adria and Ian from the tech team. So they've been co-chairs of the tech team for years and years and years now. And they're both looking for opportunities to work more solidly on CCAN. So we've been able to get them on board for at least a year. And Paul Walsh, as our CTO, is helping to coordinate activities between those 2 chaps, Sergey Motnyuk as well, and others in our team to get some core work done. A lot of that is also being currently represented on the CCAN GitHub, of course. So there might be some discussions internally to coordinate how we can best use resources, but then we're making that very transparent and open on the CCAN GitHub discussions, and there's a project up there and folks can jump in. A big part of this is kind of creating a flow of value and a flow of work and identifying the opportunities for others to jump into that flow and also carry it forward and get it moving forward as well. So whether you think of CCAN 3, whether you think of some of the key things that CCAN would benefit from in the future, like DCAT 3, DCAT 3 AP for the European standard or US for the US standards. And that's probably a good jump off point for someone like Claire, who at the University of Manitoba is data manager and responsible for one of the projects that Link works on with those folks, which is the Canadian Information Network, Canadian Watershed Information Network, CanWIN. And I've seen her chat through this before at CCAN Monthly Lives. I've followed all of this work for a long, long time, and I'm really impressed with the way she's tackled this whole project from inception through to the execution, and obviously the selection of Link as a partner to help with the project. So over to you, Claire.
Thank you very much. And thank you for the invitation. I'm happy to be here. I should be able to share my screen, right? Maybe not. You'd think I'd be a little more technical, but.
Yep, we can see it now.
Perfect. Okay, so before I start, I just want to acknowledge that I'm in Canada in the city of Winnipeg in province of Manitoba, which is in the center of Canada, no matter what Toronto tells you. And the University of Manitoba, where I work, our campuses are located on the original lands of the Anishinaabe, Innuak, Anishinaabe, Dakota Oete, and Dene, and on the national homeland of the Red River Métis. And we respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in the spirit of reconciliation and collaboration. And now I will introduce the university itself, or the part of the university I work for. So I work, as Stephen introduced me, I am the data manager for the Canadian Watershed Information Network, or CanWIN. And CanWIN is a Canadian spatial research data infrastructure, or a data ecosystem data center, and it's hosted at the University of Manitoba. It's managed by a center called the Center for Earth Observation Science, or CEOS, and we are a center within the Clayton H. Riddell Faculty of the Environment, Earth and Resources. So CEOS itself is a leading multidisciplinary and collaborative research center, and we are focused on understanding how the Earth will play, the Earth and its different systems will play a role in responding to climate change. So CEOS researchers conduct their field work all over the world, but the Arctic freshwater marine system is our unifying focus. So we work across what we like to call source to sea. While we each might work on a different piece of the environment, we want to get this system picture of what's happening in order to better inform at local, regional, and national levels what's happening to our ecosystems in terms of particularly climate change. So our team is small, but we are part of a larger collaborations, such as the Canadian Consortium for Arctic Data Interoperability, or the CCADI. And the CCADI is a pan-Canadian collaboration between 6 universities and multiple Indigenous, governmental, and nonprofit organizations. And it was started to develop an Arctic research data infrastructure with a common set of standards, so to make data sharing easier for users and data providers. And because I am a freshwater researcher, I also extended that work into the freshwater realm. So those standards, those same kind of standards and tools that you're applying for the Arctic, of course you can apply to any domain because data is agnostic ultimately. So a little bit about me, as Stephen said, I'm the data coordinator and manager of the Canadian Watershed Information Network. I'm also a freshwater biogeographer, so I look at freshwater lakes in terms of space and time, and I manage a program called the Manitoba Great Lakes Program, which I'm going to just situate you in terms of Canada. And I'm also the co-chair of what's called the United Nations Academic Impact Hub for Sustainable Development Goal 6, which is clean water and sanitation. And the University of Manitoba is the only academic impact hub in North America currently. So the UNAI SDG 6 is an example of multidisciplinary researchers working together to share their data to better collaborate and understand these ecosystem changes. Now, our data team is quite small, as I said right now. It consists of myself, a head data curator, and a research programmer who actually works for the entire department, but does a lot of work with us as well. So this is Canada, and I'm just scaling it up and down to try and give you a sense of scale of the type of areas we work in. So my lakes are the lakes to the west of what people commonly know in Canada, either the Laurentian Great Lakes, which are down here. I don't know if you can see my mouse, but I'm at the bottom of the screen on the map. The items in the box in the bottom of the screen, that's my research area. The Manitoba Great Lakes is a series of interconnected lakes that flow into Lake Winnipeg, and the water from Lake Winnipeg ultimately flows into the Arctic via Hudson Bay. So all the water from the west to BC, to the BC border, from the east of Canada, just before Lake Erie and Superior, so the Laurentian Great Lakes, and then bits of 4 American states, all that water flows ultimately through either the Manitoba Great Lakes or Lake Winnipeg and into the Arctic. So we really need to understand what's happening in these ecosystems. And the genesis of the Canadian Watershed Information Network as a data repository is actually that the government of Canada acknowledged they knew this was a problem. They knew as a government at the time in 2012, they weren't doing a great job of being able to share science research. So what they did is actually create a memorandum of understanding with the University of Manitoba to create a data repository, which I ultimately ended up working on. So the CanWIN system, this is just an example of our homepage, and it's steered by a set of principles and services that facilitate our core mandate, which is to lower the latency for real-time decision-making. And we do that by supporting the ethical and fair sharing of data across the freshwater marine spectrum, as I mentioned. I'm going to talk a little bit more about how we think about fair and care principles in our work and what that means. Just to give you a sense of our actual CanWIN ecosystem, you can see that we have multiple platforms that we use. That main page that I just showed you, that page allows a central starting point for users to be able to access data regardless of the platform that we're using to actually host the data. So for example, we have a geospatial platform, which allows us to provide geospatial layers visually. And that's one piece of our toolbox, but those layers are always also linked into our CanWIN homepage and main central site, which is the site that's hosted by CCAN. And then we allow people to search our site multiple ways. So one of the things I'm going to briefly mention is the federated search we created with Link Digital, where now users are able to access not just data from our site that we host, but data from other repositories that are hosting freshwater or Arctic data in Canada and internationally. And this is just that same idea. So a fundamental component of our work is creating those tools I just talked about. So not only for data access, but to support researchers and collaborators in how to curate data, how to make it public, and how to actually create useful data information and products from that research data, so that we can really start to make evidence-based decisions on managing our watersheds and taking that information to use for policy decisions. And so the way we do that is through sort of these 5 key tools or strategies. So we know that research data management is challenging, not just for researchers, but for data providers of any level. And in Canada, over the last decade, there has been a push by the core funders for research, at least, which are called the Tri-Council. So they're an organization of government agencies that fund most of the medical, natural science, and social science research that's conducted. And they created a policy that has just been put into action, which states that all research, big research grants must have a data management strategy in place. So that's led to an increased awareness of data management. However, the benefits to a researcher or an individual and how you can use best practices and what those best practices might be to benefit good research data management is still really unknown by people. So that is one of the key things that we do. So our data curators will work with data providers to develop discipline-specific expertise in good data stewardship. And then through mentorship, we can focus on training our early career team members or graduate students and staff, or our collaborators, including our First Nation and Indigenous partners that we might be working with. And we also support community and First Nation partners by co-developing projects and by creating tools that will support that Indigenous data sovereignty, data governance, and make the sharing of data and information products easier. So through use cases, we can demonstrate, actually demonstrate the value of behind the scenes things that you need to do to create that. So creating the interoperability piece, creating the common standards, collaborating with partners locally, nationally, and internationally to make sure we're all using a common toolbox. Those are the things that cost us a lot of money, and the funders don't necessarily see, but by using use cases, we can demonstrate better to them how the tools that we've created support all those things. And through targeted training, activities, and workshops, we can promote a shift in data culture to help build a more sustainable and collaborative research community. So to engage our researchers, one of the things we do is highlight the benefits to them. So our platform was developed by keeping in mind, we were lucky because we were able to redesign ourselves in just around when COVID happened. So the ideas of not just FAIR, but the CARE and OCAP principles of data sharing had really come more into play. So we were able to lean on them to have that at the top of our minds when we were redesigning our platform in the first place. And so that allows us to support the ethical and collaborative sharing of our data, of our research data. And it allows our partners to be able to be the data holders. And essentially us at the university, we often are acting as a trusted third party for that data. And we are able to engage early in the process with groups like undergraduate students, like students, even early career researchers, as well as our community and First Nation collaborators. And so we are able to set the building blocks for that sustainable, reproducible data workflow. We are able to then essentially create data experts who can specialize in their area of research and understand how to best curate the data for that, and then translate those tools if they move into other fields. And we can provide support for understanding what the best practices might be for collecting data, storing data, sharing it, and analyzing it. So in that middle box there, it's small, I apologize, but it's a basic workflow from what happens in our case from the time we take an instrument out and use it to measure and take a data point to the end product of producing information, not so producing the data set, which a researcher might want, but also producing data products in an understandable format for multiple stakeholders. So because we are a research center and we're heavily intensive research center, we use a lot of different types of instruments, but those instruments are used across the entire land-ocean continuum. So we work with researchers a lot to create these workflows for an instrument using best practices and using reproducible tools so that they don't have to keep going back and figuring out how to download that same type of data because they used it in a different area, or because the technician they had hired to do that work has gone now, and now they need to start all over again. We can cut that out by creating those reproducible workflows. So the key to sharing all that type of complex and relational but non-standard data that we collect was really, it started with the creation of multiple templates. So our data providers, whoever they are, can share multiple levels of detail or metadata about their data. And we can associate multiple types of disparate information back together. So you can see on the screen here, that drop-down box is 7 different types of templates that we allow our users to use. So even before a project, so in our case, we actually work at a project level. So a project might be anything from me just collecting research on lakes using 4 different instruments to multi-million-dollar programs where you've got an overarching program umbrella, and then you've got multiple research teams under that program umbrella. And those programs are typically, or always, multi-university, multi-nonprofits partners, multiple industry partners. So they're really complex and they're really big, and we needed to be able to keep track of all that information and provide it back out in a way that people could understand. So in this instance, you can see that we can capture all the information about a project, everything from the project itself before it even starts to collect data, to the instruments used, to a deployment means that you've taken an instrument and you've put it to measure something. And you may take it out again, or you may leave it in for months or years. So you can see in this picture, we also record platforms. So at the bottom, we've got 2 different sizes of vessels. Both of those are platforms you might conduct research from. We've got an instrument in the top corner, but it's actually a platform because it's got multiple instruments on it. And those instruments might be swapped out during the course of a year, and you need to know that in order to be able to track the quality of your data properly. So with the multiple templates and being able to record that information in one spot, it's really elevated our ability to do that. So every piece of information that we collect is called a research output. And that allows us, like I said, to better track the types of information that's associated with a product. And so what I'm trying to, I guess, emphasize here is that data is important, but without all the associated, what we would consider normally metadata, you lose the value of your data because you no longer have data provenance. So that data provenance piece is what's really, really important for reproducible research. Because if you don't know anything about the instrument that collected that data set, even though you might have been analyzing that type of data for 30 years, you can't really prove the quality of the data necessarily if you don't understand how it was collected, the methods used, protocols used to analyze it, and that includes the type of instrumentation used and the methods used. And we can also associate back other information with a project. So publications are important, but so are images, so are reports, so are those methods. And from the user end, this means that users can conduct a smart search via a toolbar. So this is on the main data catalog page. And when they do that search, the search results will tell them whether the information they're looking for is a project, a data set, an instrument, a publication, basically any one of those 7 templates. It will tell you what type of data you would get back. So you can narrow down your search multiple ways. And we also created what's called collections. So this is where allowing researchers to be able to access what I would call that disparate type of information or information across multiple domains is important, particularly when you're talking about ecosystem science. Because I'm a freshwater researcher, I have a domain-specific knowledge about analyzing freshwater water quality data. But if I want to look at how climate change is affecting my local lake even, I need to understand perhaps the climate change trends that are happening globally and nationally. And sometimes there's not great data for that, particularly in regions in the prairie provinces, or if you recall that map I showed you, in a lot of those regions in Canada, because we're a big country, we have a lot of gaps in data collection. So groups like citizen scientists who are coming in and monitoring data with this use case I'll talk to you about, when we can help them collect their data, not only because it's important to them, but to provide them the support they need to make that data defensible and scientifically sound from a Western point of view, let's remember, then this not only helps them support themselves in data sovereignty and governance, but it also helps us as researchers, because now I have climate data at a hyper-local scale that I never had access to before, for example. And then I can take that data and combine it with other types of data that I need to understand the multiple effects climate change might be having in my region. So when I talk about those FAIR and CARE data principles, so the FAIR data principles are findable, accessible, interoperable, and reproducible. And so we're really good at finding things as researchers. We're not really great at making them particularly accessible. We're getting better at interoperable. That's what a lot of the work we did in the last couple of years was done with the consortium. So making things interoperable globally so that all of our systems can talk to each other. But there's also the other piece, which is really making that data accessible. So it used to be acceptable to just take your data set, publish it online even, and write a journal article about it in technical language and publish that. And that was great. You've done your due diligence. Now your grant money is done and you move on to the next project. But that causes all sorts of problems, not only for reproducibility, but for ethical data practices these days, and just for actually supporting sharing and understanding of ecosystem change. So to make data accessible, we need to make it accessible not just at a technical level, which we can do through things like creating standardized or utilizing metadata schemas. Because the one big thing I ever learned in data management is don't recreate the wheel. Use the tools that are there. Just work with other groups to make sure you're all using similar tools or tools that can talk to each other. That's the key piece there. So in our case, that means we used schema.org as our core metadata schema. All of our partners use schema.org as their core metadata schema. It's searchable by multiple hundreds and hundreds of repositories. We used that federated search that I told you about. So we provide users with the ability to not only search our site, but to search other freshwater sites in Canada and the Government of Canada website. And we do the same thing on our Arctic partner site. And the goal is to one day have people able to access both of those portals from our page as well as our partners' pages. So essentially, as a user, you know you can go to your preferred search research site and get the same information because we've all been able to share it. And because we've used things like standard metadata schemas and semantic interoperability, which basically means using common language for common language tools, that means that you as a researcher or even as a citizen can actually know that dataset A is comparable to dataset B. Because the other piece that I'm not going to talk about today a lot, but is a real issue, is the fact that, again, without the background in knowing how the data was collected and analyzed and processed, you don't know if, even if the variables like phosphorus from dataset A, you don't necessarily know if phosphorus from dataset B is the same. But you can use things like semantic tools to use a standard vocabulary language to make that known. So we were able to incorporate a lot of those principles into the redesign of our site and through working with partners in the freshwater and the Arctic world. So that's the science and the technical piece. But that still does not have the accessible piece for the rest of the world. So we're very good at looking in their little boxes and going, oh, that's great, it's understandable. I know what this means, it's great. But I guarantee you when I'm looking at ocean data, even though it's the same variables, so nitrogen, phosphorus, or what I look at, for example, it's not necessarily the same to everybody else. And at the end of the day, a journal publication is not going to have the impact or contain necessarily the really key points that you need to get across to a funder, to a policymaker, or to the communities that were involved in the collection of the data, or answer the question that they actually asked because your journal publication was so very focused on one piece of that. So we need to be able to produce information products, and information products in a way that the people that need to understand them can understand them. And so we call that storytelling, for lack of a better term. So that means we create things like story maps. We create data dashboards, which I'm going to show you a bit of. And we've created things like graphic novels. So at the bottom of the screen here, you will see that on the left would be a project page. So this page would show, it was created for a research project in Hudson Bay, looking at the impact of water vessels on beluga whales. because as water opens up, as ice is off longer, you get more and more water vehicles, whether they're motorized or kayaks or paddle boats, in areas like Hudson Bay, which are important areas for beluga whales. So one of the researchers used drone imagery and wanted to know if they could use artificial intelligence to differentiate between a beluga whale and a water vehicle. And so all the research data is there, all the images are there, all the journal paper links are on the left-hand side, but we also created a graphic novel. So the graphic novel is a great way to tell the story of how that project went without all the technical details that would bog you down and make an otherwise interesting project incomprehensible to a lot of people. So the graphic novel summarizes those key points in a way that people can really digest. And they're all available from that project page. So for my use case, so I'm going to talk about one of the projects we are still working on, still co-collaborating with, I guess would be a better term. So this was a program that began a number of years ago with the Manitoba Métis Federation, and it was to create a weather keeper program. So it's a community-based monitoring program where Métis citizens allow weather stations to be set up on their land. The weather stations are streaming data back into our system. Now, we use the Internet of Things and OGC, Open Geospatial Consortium standards to make a common endpoint for that weather station. So that meant that we created tools to allow us to ingest multiple types of weather stations, regardless of the logger box that actually sends the data out. Now, the reason this was important to the Manitoba Métis was because, so if you remember back to that image I showed you of the Manitoba Great Lakes, those lakes are lakes that are important use areas for Métis citizens as well as many others. They use them for recreational fishing. They use them for subsistence fishing. There used to be a bigger commercial fishery, but there still is a commercial fishery on those lakes. But there's almost no Government of Canada weather stations around those lakes. So I realized this when I, as a researcher, had massive problems trying to figure out if I could actually go out and even conduct research on the lakes, because they're big lakes, but they're shallow. So you can only use a very small boat on them. So we have a 16-foot boat that we tow around. So you can't use that boat in very, very bad weather. And also I was doing some work that required me to have calm water. So we realized there was no good weather station data. And we talked to a lot of people around the lake, including some people from the Manitoba Métis Federation, and they were really interested in this. So ultimately, it was decided that we would start with collecting weather data. And then through the co-collaborative process, what that means for us is that we host the data for the Manitoba Métis Federation. They have their own data page. There's a big logo on the right-hand side of their program page that says they are the facility owners of that data. The citation is for them. We are cited on it as well, but they are the lead authors. And we curate the data for them. We created data curation workflows for them, which we're going to talk about a little bit. But we also created technical manuals in collaboration with them. All the documents and key materials that we created were produced in English, French, and Michif, because those are the official languages of the Métis. And also we created user manuals for the citizen scientists that were going to be managing the weather stations. We created technical manuals that we use yearly to train Métis Federation technical staff that are going to be working on the weather stations, and that we can update so that it's usable and understandable for them. So all this is hosted through our site, through CanWIN, using those multiple ways to relate multiple information that I talked about that was created. But the Manitoba Métis are the owners of that data. So they're able to then take that information and use it to inform policy if they want to, or inform their government. And the reason they wanted it was to inform their citizens, so their citizens could check the weather essentially around those lakes. That was the first driver. But again, because there was multiple requirements for wanting to use the data. There was the Métis citizen that wanted to just look at a weather station dashboard like you would and check the weather. Then there was the wanting the ability to view the data without having to use it. Stations that might be in the area, but you don't have the capacity to create a script to download the data and clean it up and analyze it, and you don't have the technical skill to understand weather station data, because that's what climate scientists do. So we provide that bridge. We create tools to allow users to do a lot of that work in collaboration with domain experts. And then we create instruction code books and cookbooks, we call them. So the code book would be the overall instructions. The cookbook would be the code book would be the details about the scripts created if you really wanted them. But then there's user-friendly interfaces so that you don't have to have the technical expertise to actually recreate that script, but you can still do the data analysis. So here you see at the top is the simple dashboard that the citizen scientists wanted. It has the data on the left and graphs on the right, and it's near real-time weather station data because it updates hourly. At the bottom, we created a beta smart mirror. So that mirror is like an 8x10 mirror picture frame, which is powered by a Raspberry Pi, and it cycles through all the weather stations that are online and lets you just view the data in a rotating basis. And that sits or will sit in the Métis president's office. And it could be scaled up to be, a giant monitor screen if you wanted it to be. And then because we have other platforms, so we have a geospatial platform, so we're able to provide visual maps of the data. So each sensor of the weather stations was streamed into the Geo node, which is our open source platform, as sensor layer. And then that information is provided. You can see on the bottom left is actually a Métis weather station, Métis Federation weather station. So it's got the variables on the left. If you click on any of them, you'll see a graph. And if you want to compare to see if there's any Environment Canada weather stations close, you can click on this additional station button at the top, and it will overlay any weather stations in the area of interest. And then you can compare variables. So here we're comparing 2 Environment Canada weather stations with the Manitoba Métis Federation weather station data, and you can see how close they are, how similar they are, to give you a sense of how well your stations are performing compared to the government station. And you can subset this data and you can download it. And then the third thing that the Manitoba Métis Federation wanted was an easy way to tell that story. So they created what's called story maps. So these are again created in our mapping platform. So they allow us to have those interactive mapping layers accessible, but they also allow us to put images and text on. So there's a whole story map that users can view and multiple tabs full of information that they can scroll through. And then this year, the Manitoba Métis wanted to have a more straightforward dashboard to actually do sort of that data analysis piece. So this dashboard was created more for the MMF staff that would want to maybe go in and do some of the data analysis. So the code is written in Python. We use an external data platform to easily create and host these interactive data curation tools. But again, all of that is documented and available to the Manitoba Métis. And we would train them on the actual data analysis if they wanted to do it themselves. But if they don't have the time or the capacity to do it themselves, we will work with them and support them in that analysis. So here users can go and choose the actual weather station, or they can choose to plot the weather station and compare it to the closest Environment Canada station. So if you just choose the weather station, you can choose the variable you want to view. And they wanted a way to compare it to last year's data. So it'll tell you what last year's weather data was, maximum and minimum, and then it'll plot the data at the bottom. And all these plots are interactive, even though you can't see that. So if you highlighted a section, it would zoom in and zoom in. And if you hovered over any of these dots, they would they would show you the data point. And you can also download the data. And alternatively, if you want to compare your weather station with the closest Environment Canada weather station for further analysis, you can simply choose that option from this. So plot both, option 2, and then choose the variable again that you want to compare. And now you've got a plot of both. So ultimately, we can view over the life of this weather station how similar these two data sets are. And while we know that the Manitoba Métis weather station is reading a hotter air temperature, it's also consistent. So we can do a bit more analysis on this and ultimately say perhaps, yes, the station is reading hotter, and we know why, because we know there's limitations to the station. They're 3 meters high instead of 10 meters high, et cetera, et cetera. All that, again, was documented in the deployment and the instrument details. So anybody can go and look at that information. But what we would do in this instance is work with the Manitoba Métis, give them the confidence that, yes, this data is comparable, it trends the same. You can use this to inform your citizens. You will just know there's always a 2-degree temperature difference. And then they can now take that and use it to inform their strategies for climate or weather or whatever other use they want. And to give you an example of how they have been showcasing their weather station program, they actually took this to COP, so the Global Climate Conference that occurred in Egypt in 2023, I guess it was, or early 2024. They took this, and this was one of the pieces that they showcased to the COP group for how Indigenous self-governance and support for data can look. And this is just another example of that, but a tool we created for reproducible research data analysis. So in this case, we have an instrument called a Seabird. A Castaway is a similar instrument. This is deployed off of a ship. It's a profiler, so it's going to take a sample from the surface to the however deep it's lowered and all the way back up at usually high frequency intervals. So say every 5 or 10 seconds. Oh, here we go. Every 5 seconds, it's taking a sample. And you can see it's pretty messy data. So when you download this data, you will see, for example, there's 25 to 29 lines of metadata before you even get to the data point. And what happens in our organization is that a researcher may be in charge of that instrument, but they may have multiple technicians that they need to train on how to analyze and curate that data. And those technicians will change over time as they move on to new positions. So how do we standardize that process so the researcher does not have to continue to train someone, and that there's a consistent way to process data? And because these instruments are used often across organizations, are we using the same best practices that our partners are using? So we work with our partners and the researcher to figure that out. And then again, we create that data workflow by writing the scripts and then providing a user-friendly interface for them to actually curate their data. So here they can choose the data, upload it, choose the header. It'll try and figure it out for you, but you can change it. You can choose a number of other options, and ultimately then you can plot and download the data. So instead of that process having to take multiple days for a new technician to figure out, or for the researcher to have to stand over that technician to make sure they're doing it properly, they can upload hundreds of files at once to this tool, this app, and get the data they need off it quickly. And so that's my overview of where we currently are at and how we're trying to provide support for reproducible research. And some of the things we're hoping to improve are things, a lot of it's based on user feedback. So really just providing better ways to highlight and showcase those key research pieces. So researchers are wanting to be able to showcase not just their raw data or their curated data anymore. They want to showcase those data products. So on the left is a current example of a program page. And this researcher also creates, for example, plain language summaries in multiple languages. And right now, the only way we can highlight that is by, hyperlinking words. So we've looked at a lot of examples around And we thought perhaps using Showcase or some other extension that's not created yet to create these thumbnails that are hyperlinked so people can see, get a better sense of what they might be clicking on, and then click on that image to be taken to the appropriate location. And that is my summary of our work. So thank you very much for listening. You are more than welcome to reach out anytime. We'd be happy to hear from you. And if you have any feedback on our site as well.
Wow, like that was amazing. I don't want to overblow it, but basically I've been thinking about stuff over the last couple of weeks in particular. And going through that presentation, it's just good to reflect on all those thoughts with such a clear example that kind of captures a lot of the things I've been thinking about. So to give you an idea, like open data, starting from this, like open data for jurisdictions, for public domain, government type data. You can kind of think of that as a social science. How do we all agree that our public funds are going in the right direction, that our public policies are being targeted towards the right outcomes, that there is clear evidence that we're doing the right things by our economies, by our different programs, whether it's infrastructure, healthcare, or whatever. It's hard in the social sciences to get anything specific, but the examples you were talking about there in terms of measurable data, objective reality, gives us a baseline for how to look at things. So the instrumentation matters, the platform matters, the lineage and the change over time matters. You can't reasonably understand any kind of outcome of a measurement unless you understand the inputs that came to that outcome. So just how specific that is really important. And maybe that's why there's such a cloud over open data from that jurisdictional kind of point of view. Open, transparent government, things like that. But the other part I really appreciated was talking about accessibility from the point of view of the interaction back to the public. So it kind of reminded me of, I was reading recently about how people accommodate or assimilate things that they come to know. That to accommodate something means you incorporate it into the way that you would behave or act or expand your worldview into the future, whereas assimilate, you might just categorize and put off to one side. And it strikes me that accessibility when it comes to data stories is really about picking the right folks who will accommodate it. So the story of the Manitoba Métis, who will incorporate the data that you're looking at from the freshwater perspective, the weather perspective, build it into the way that they might manage the environment, have a relationship with the environment, talk to their people and work with it, is a great way to transform from scientific objective realities and data and instrumentation through to impact with people who will be likely to take on the knowledge that's there and accommodate into how they move forward. Yeah, so it just felt like a very great case study from start to finish. I got a lot from that. I want to ask though, where to next, and what kind of lessons are you learning from this complete exposure to all of this data and all these different data portals? Where are the gaps that you see at the moment, or what's the next steps, do you think? Oh, I think you're on mute still.
Right, thanks. So I would say one of the gaps is in terms, so there's the communication piece, which is a gap in the sense that we still have to bridge it between researchers, what we currently do and what we could do to make this a better experience for everybody, right? So going into communities and providing these reports back, that's an education piece to our research groups, but also to the funders. The really key piece here is that the funding agencies, the model they have set up for funding research doesn't allow this kind of community engagement. So first of all, you have to basically have a relationship with the community before you can build that trust level. But most grants, right, or you get 3 months to apply for it. You have to have a pre-existing relationship. So if you're an early career researcher, or you're coming in from somewhere else, that's really hard. And then there's no supported funding when that program ends. So because I'm the data manager and a researcher, I was able to bridge that gap with internal funding and create these use cases that allow us to understand how we can better do this and what that would look like and if that's actually helpful. But most people don't get that opportunity. So that's a big problem because our funding agencies are basically telling us on one hand, you need to be able to do this co-collaboration, but we're not going to give you any money or any time to do it. So just sort yourselves out, right? And then I would say the other piece is understanding that collaboration really does have to be key at that interoperable level still. So one of the things that happens is you get funding to do something, you think, I'm just going to build this great tool. I have systems developers who can build this for me, but then they build them as standalone products that they didn't consult with other existing organizations for, because in the past, right, the belief is someone will try and stop you from doing what you're doing. And that's not the case. The case is funding is limited. We can all do something well. Like I'm not ever going to be able to do, let's say, a certain type of data set well, or maybe somebody else can. So the one thing I learned from the CCADI collaboration, let's say, is that not only how to collaborate on best practices for analysis, curation, semantics, but also the fact that, so this is an instance where we have researchers going on the same ship that puts their data on another data portal. But now through this creation of tools, it doesn't matter where the data sits because we can pull data from all of our portals and share it to our users. And that doesn't happen a lot. That took a $5 million government grant to be able to build the communication level so that we could do that and the tools to do that. But now we've done that. That's a really good use case to show. I use it in the freshwater world with Living Lakes, for example, just to show these repositories are all important. They're all going to do something different well, but as long as they build the tools in or work towards having tools that they can work together, then the value is still there for the citizen, for the Canadians, for globally, right? We're not fragmenting that landscape any more than we need to. We're just building up stronger relationships between data and making data easier to find. So that federated search piece, I think, is a huge gap. So as I was telling you earlier, when I was looking for sites to federate for our test case with Link Digital, I realized that the government of Canada had at least 4 open data sites, and they're not all built on the same platform, so we can't even easily federate them all in. And some of them are sharing out the same data in multiple platforms. And to me, like that's my taxpayer money that they used to build things over and over just because they were slightly different agencies that thought they needed to do that well.
Yep.
That makes sense.
Yeah. No, it's really interesting because again, another thing I've been thinking about recently is the different types of funding that have different types of timeframes for outcomes. And it strikes me that a lot of the funding is kind of ephemeral and temporary. And I kind of put it into this basket of a contributor ecosystem. There are lots of folks contributing to solutions, and they have a good theory on how they can contribute or something testable. They have some great predictions on what kind of value might come from the work they can contribute into a field. And so a lot of the activity is there because that testability and that sort of verification and prediction and that's the sort of thing you can get funding for a period of time. But sustainment of the conclusions or sustainment of the platforms that would kind of lean into that problem over the very long term is much more of a public good or a public infrastructure or a public capability. So I'm kind of leading a bit here because I know that you mentioned that the Sustainable Development Goals, I think it was category 3 or 6, freshwater.
Yeah.
Yeah. The Sustainable Development Goals, CCAN is a digital public good. There's that crossover there where we can have these public goods that have long-term sustainment and they can be supportive of long-term outcomes for the public. And it strikes me that crossover between scientific understanding of the world around us and then the public intent to use that knowledge and accommodate it into the way we support civil society is a great long-term thing that should be sustained through public funding. So there's, I think, ecosystem development and building contributors together, accommodating different populations and interests and the impact that different people can get from knowledge all of that is really great for what I call, I guess, transactional funding. But the long-term foundational funding of these programs and these activities globally, I think they almost need their own foundational funding. And it's persistent, billions of dollars, and then the earnings from those billions of dollars, the economic outcome of investing those dollars into other devices, financial devices, the earnings would then support the sustainment. But yeah, maybe it's a long-term project. We've probably got questions. I haven't looked at the chat, but if anyone wants to jump in, put their hand up, please go ahead. While I have a quick look, unless Kate.
Well, actually,
everyone's saying awesome.
Yes.
Oh, we're very close to the end too. Sorry.
Well, that was me, so thank you for listening to me.
Yeah.
It's
Well,
actually really good. Yes. We
yeah,
don't have
I can
much
only
questions.
recommend.
Sorry.
Yeah, I can only recommend everyone reach out to Claire, connect with her on LinkedIn, ask her some questions, not necessarily specifically, generally, because what I've observed over the years is that Claire's done this project. She's pulled it all together with all the different stakeholders. She's had a clear understanding of what the tooling of the infrastructure platform can do for the science, but also that sort of social dynamic of how to bring different collaborators together, how to meet the different needs of all stakeholders. And I think good technical tools do that. They support and they enhance the capability of collective agreements or collective value statements. So yeah, I think it's a great project. And I think the more people pay attention to CanWIN and the work that Claire's doing, the more everyone will learn and benefit. But yeah, thank you, Claire. And thanks everyone. Just on time, right, Kate?
Yes, thank you so much, Claire. That's really great, very informative, and easy to digest as well. As for someone who isn't, very technical in terms of understanding the very deep technical on data on the portal itself. Yeah, thank you as well, Stephen, especially to our attendees. We appreciate your sharing your time, and your feedback actually is very important. So once you have left the forum, there's a survey that will prompt on your screen. So we hope to see you in the next one. Truly appreciate everyone's time. Have a great day.
Thanks, folks.
Thank you,
Thanks,
Claire.
Claire.
Bye.
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 Education for everyone.